All right, this is Mr. Warwick. I'm here to kind of go over these notes with you. I should be back in class tomorrow, but we're just kind of looking at something like this here. So a system of inequalities is more, if my pen would work, more than one inequality. Okay, so we had the four inequalities. Less than, where it's a dashed line and we're shading below. Greater than, where it's a dashed line and we're shading above. Less than or equal to, where it's a solid line and we're shading below. Greater than or equal to, where it's a solid line and we're shading above that. So those are the four ones that we deal with normally. When we have a system of inequalities, we're going to be shading multiple sections and there's going to be overlap between them. If we want to use like multiple colors, something like that to really show that, you can sure do that. I'm just going to be using one because I anticipate that's what most of you will have. So when I go to graph this system of inequalities, it's x plus y is greater than 3. I'm going to treat that like equal to 3. So I'm going to set my intercepts on 3. That's just because if I cover up the y, it's got the x is 3. If I cover up the x, it's got the y is 3. So I'm able to place those points. There's no equal sign here. So I'm talking about a dashed line there. And this is saying when I add them together, they should be greater than 3. So in this case, greater than 3 would be 4, 5, 6. I'm talking about up here in this area. So I'm going to kind of lightly shade that in. Y is greater than x minus 1 would start down here to -1. It has a slope of 1, so it kind of comes up on this line, on this diagonal here. And so when we do that, again, this one doesn't have an equal sign. It's a dashed line. And because this is greater, 0 is greater than -1, 2 is greater than -1 right here. So this area that I'm going to kind of shade lightly is the correct answers for that inequality. So this up in here, where these cross over each other, where these double shade, is going to be the solution to the system of inequalities, okay? So it's unbounded. It keeps going forever up in this direction, but it does have these boundaries. Any points on the line would not be included in the correct answers, but anything in this double shaded area is going to be a right answer. You can definitely use the calculator on this. You can use Desmos, and both of those are going to be some pretty good tools to make sure that you can figure out where your double shaded region is. On example number 2, Jenna spends at least 80 minutes and at most 150 minutes a night on math and science homework. She spends at least 60 minutes on math. So going across the bottom, I'm going to call this my math homework. And I'll say each one of these is, what do I have? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So to get to 150, I'm going to make each one 15. So 15, 30, 60, 90, 120, 150. She spends at least 60 minutes on math. So I've got this dead equal to 60 minutes, and I'm going this way on my math. This is my science. I'm going to do the same thing here. So I got 30, 60, 90, 120, and 150. She's spending at least 80 minutes combined. So that would be, if I spent 0, I spend 80. If I spend 0, I spend 80. That's going to be right in here on this. And then she spends at most 150. So here's my 150, my 150. And that's going to go like that. I'm shading down from this line. I'm shading up from this line. At least means I can do more. At most means I can do less. So this is shaded below this line. This is shaded above this line, and we're shading to the right of this one. So only this little trapezoidal area down here is where all three of these are going to be intersecting. So anything out in this area is going to be something that's a right answer. I could come over here and I could say I spent, 105 minutes studying math and then 15 minutes studying science, and that would work. And all these little partial values in here are also correct, so you can get those 30-minute segments, it still works. When I graph this, remember how to graph absolute value. That +2 means I'm going 2 to the left, +5 means I'm up 5. The negative is going to turn it down. So then after that, this should actually be a dashed line. we're shading above it, so I shade up from here. Y is greater than or equal to 3, so I have a solid line here at 3. I'm shading above that, so it's this outside area around this. Is 1, -2 a solution? I go over 1, down 2. No, it's outside. 0, 5 is up in here. It's in that shaded area, so yes, it is. If we had one that was like on this line down here, it wouldn't work because it has to be above this line. If we had one that was right here on this, again, because this is a dashed line, that's non-inclusive. So that would not be a correct answer. It has to be up into the segment. We'll kind of go through the rest of these when I get back tomorrow. You should have an assignment. You should be able to get through most of it by graphing. If you have questions, save them until I come back.